We have one corner in our basement that has literally never been touched since the day we moved in. Now that we have 3 kids and the need for more playing area in our basement, my wife and I decided to consolidate all her sewing stuff into one part of the basement. Apparently fabric is to sewers as scrap wood is to woodworking. So my third COVID-19 quarantine home improvement project, I worked with her to clear out the area. Then I added a worklight with a motion sensing light switch. You can see it at the top of the picture here. I re-insulated the joist bays and added electrical on a new circuit. This is the time-lapse video I recorded of that project using my Raspberry Pi time-lapse camera, and there's a link to how I used that, the software for it, in the description below. I started out re-insulating the joist bays using rigid foam insulation. The bays originally had loose fiberglass insulation, but that's not recommended for joist bays because it's very leaky, allowing air to circulate against the house's rim joist, which can lead to condensation and rot over long periods of time. The process for the insulation is pretty simple. First, put on a mask and safety goggles to remove the old insulation because it's got a lot of nasty dust and glass fibers in them, and they'll irritate the heck out of your lungs. You should probably wear gloves too. Then you take out the new insulation and cut out sections to fit each joist bay. And I use 2 1-inch layers, but you can use a different amount depending on what region your house is in and how much insulation you need. You secure them in place using foam board adhesive. I used Loctite PL300 that you can get at Home Depot. And to finish it off, since there will be gaps around the edges and around any penetrations you had to cut around, you can use low expansion spray foam insulation. And it's the door and window kind at the hardware store around the edges of all the foam. In addition to providing better insulation for your rim joist, this looks much nicer than the nasty old fiberglass bats that were jammed in place and are now full of cobwebs and even little critters sometimes. My wife wanted to be able to run her sewing machine, an iron, and be able to listen to some tunes on a boombox. So I made sure that there were at least 4 wired outlets, 1 receptacle on each wall. This is the part of the video where I have to give a major caveat. Mains electricity is dangerous, and using the wrong breaker, outlet, wiring, or fixtures can and will lead to fire or electrocution. You're responsible for not only complying with any local electrical building code, but also getting proper permits as required by law. Anyways, here in St. Louis, Missouri, and the USA, basement wiring can use NM or non-metallic wiring, as long as it's secured inside joist bays every 6 feet. Anywhere below the joist bays, it must be installed inside EMT, which is electric metallic tube, conduit. Other parts of the country and world are different, so don't just do what I did, do it right according to your local building codes, or even better, hire a licensed electrician to do it for you. That out of the way, I finally bought a pipe bender since I couldn't borrow my dad's due to COVID-19 and social distancing. I ran 12-2 NM wire through some 3/4 inch holes that were in the joists that already existed for other electrical wiring for the garage. I terminated the wire in a metal junction box in the joists, in the joist bay area, then ran NM wire through an EMT riser that I screwed into the foundation wall as well as the sill plate. Then I bent a long EMT pipe to go around the foundation wall to the other side of the new sewing area, and I finished off the run with another outlet. I finally switched off power to the entire house, and careful of the still energized 240 volt feed, I terminated the new circuit in my house's main electrical panel using a combination AFCI-GFCI circuit breaker. In my area, code requires GFCI for almost every outlet in the basement or crawl space. I could have used a standard breaker and installed a GFCI as the first outlet in my run, but this way I don't have to worry in the future if I want to run any more outlets from the junction box I installed in the ceiling. It's important to test everything and make sure it's wired correctly. I have a little outlet tester with a built-in GFCI tester, and all you need to do is walk around to the outlets, plug it in, and press the button, and make sure the breaker trips. I also made sure to add labels to the main panel and the outlet covers to indicate they were protected, and needed regular testing to ensure safety in the long term. After cleaning the floor thoroughly, my wife and kids installed some cheap commercial remnant carpet squares, and we moved all the sewing furniture in place. I have plenty more home improvement projects to go. Hopefully, I'll be able to capture more of them with my time-lapse rig. If you liked this video, please consider liking it and subscribing to the channel. I'd also be extremely grateful if you'd support me on GitHub or Patreon. Thanks for watching.